this experiment, you will get to know measurement methods for determining the specific heat capacity of various materials. To heat up a body, you have to supply it with energy. The specific heat capacity is a material property that indicates how much heat energy needs to be absorbed by a body so that the temperature of 1 kilogram of the material changes by 1 degree Celsius. Therefore, the specific heat capacity always plays a role when materials are heated up or cooled down. For example, when cooking food, freezing a biological sample, or heating a room. In this experiment, the specific heat capacity of different metals is measured: aluminum, copper, and iron. For this purpose, we use a so-called calorimeter. This consists of an insulated cup with water of a certain temperature, a stirrer, and a thermometer. In addition, there is a hot plate and a scale. First, we fill the cup in the calorimeter with cold water and measure the masses of this water and of all metal bodies. Heat the aluminum body in boiling water to 100 degrees Celsius. In the meanwhile, measure the insulated water bath in the calorimeter for 5 minutes every 20 seconds. Now, insert the heated metal body into the water bath and measure the temperature for the next 2 minutes, if possible every 5 seconds. Then, every 20 seconds for 3 minutes. To achieve a homogeneous temperature distribution in the calorimeter, the stirrer should be switched on each time the temperature is measured. Determine the initial and final mixing temperature by extrapolating the measured values. For the copper and iron body, the procedure is repeated in a simplified way. For these, measure only the initial temperature before the insertion of the 100 degrees Celsius hot metal body and the final temperature of the calorimeter after insertion, when it is in thermal equilibrium. Finally, the heat capacity of the calorimeter itself must be determined. To do this, carry out a simple mixing test. Fill hot water into the calorimeter and then mix it with cold water. Measure all required temperatures and masses before and after mixing. With the recorded measurement data, you first determine the heat capacity of the calorimeter and then the specific heat capacity of aluminum, copper, and iron. You can also check the validity of the Dulong-Petit rule for the 3 metals.